Well, hello again, everybody. What I want to talk about today is one of the most versatile forms of hypothesis testing that we can do, which is using the chi-square test. Now, you might say that in regards to the chi-square, versatility doesn't actually seem to be reflected in it. I mean, when we talk about a chi-square test, we're really talking about a hypothesis test looking at whether or not there seems to be an association between these two variables, and those variables must both be categorical. Now, one thing that I've always tried to note here is that when we think about the different levels of measurement, when we go from nominal, ordinal to interval to ratio, one of the things we note is that we can always go backwards on that, which is a ratio variable can be recoded to categorical, either nominal or ordinal, but of course it can't go the other way. Now, the utility of this is that if we run into a situation, for example, where later on where we're talking about something like a t-test or an ANOVA, and we have a ratio level variable, but which isn't normally distributed, and there's no way to transform it so that it can in fact be normally distributed, well, we can always recode it into a categorical measure, and then the chi-square becomes a fallback for us. Now, the only restriction we do have to mention here, of course, is that when we run a chi-square test, we have to make sure that our cells all have a minimum of 5 cases. Otherwise, it raises some issues about the interpretability of the results, whether or not we can actually trust the significance test to determine in fact this relationship does or doesn't exist. Now, in SPSS, running a chi-square, when we're taking a look at the relationship between these two categorical measures, is actually very simple to do. So what we're going to do is we've got here the 2014 General Social Survey, and not the full survey, obviously, but this is just a little subset that I put together to make it easy for us to use. And of course, this is shown up in some of the other videos as well. And you can see that with the exception of the variable of year, which technically is not a variable since it doesn't vary, all the cases here are 2014, and the variable of age, which is continuous, all of the other variables here are going to be categorical. We have marital status, race of the respondent, sex of the respondent, their income along a ordinal scale, and then finally their response to a question of fear, whether or not they are afraid of walking alone. So what I can do here is, and let's switch over the variable view and we can take a look at this a little bit better. You can see, of course, everything we said is spelled out there. And here, of course, is our variable of fear, afraid to walk at night in their neighborhood. And we can see that here, this is coded as a yes-no question. And obviously, while there are 0, 8s, and 9s for don't know, not applicable, you can also see that all 3 of those values, 0, 8, and 9, are showing up over here as missing values. So in other words, when we run our analysis, the 0, 8s, and 9s all are getting dropped out in regards to actually running hypothesis tests. So the only valid responses that we will have for our analysis of the variable of fear is the yes or no response. Now, we can take a look here across ultimately all of our other categorical measures. Now, what I'd like to start off by doing is actually focusing on the variable of sex. Now, obviously there actually is a great deal of research that looks at this relationship, but I also like to start off with the variable of sex here for the simple matter that it also is, with the General Social Survey, is a 2 categorical response, only males and females. So in essence, looking at the relationship between men and women on this variable of afraid to walk at night in the neighborhood gives us the simplest form of a chi-square analysis that we can actually do. So let's cancel out of this. And then what we're going to do is we're simply going to go up to Analyze. And now I know you're probably going to be looking for a chi-square somewhere on this list of the different types of analyses. It's a little bit strange in SPSS, but it's also because, again, the chi-square isn't seen very often as a particularly strong form of analysis. It doesn't have its own section. But if you go under descriptive statistics, about halfway down, there's an option for crosstabs or cross-tabulations. So let's select that. And once we do, you can see here we've got our rows and our columns, different layers. We also have the option on the bottom left to display clustered bar charts or suppress the tables. We're going to ignore all of that for right now. All we're really interested in is looking at the relationship between these 2 variables that we've talked about. Again, our independent variable here is going to be sex, and our dependent variable is going to be this measure of fear. Now, people will sort of argue in terms of whether it's more appropriate for our variables to be rows or columns. The truth of the matter is, with a chi-square, it honestly doesn't matter. Your results are going to be the same. The way we interpret it's going to be the same. In this case, for columns, I'm going to say that is in fact our dependent variable, afraid to walk at night in their neighborhood. And then for sex, I'm going to make it the rows. All right. Now, if I simply say OK here, and actually let's do that just to see what happens. You're going to see that the results that we get are really very straightforward. Here is giving us exactly what we asked it for, which was a cross tabulation. There is no chi-square statistic associated with this. It is merely a frequency count across the 4 cells. And again, the 4 cells are representing yes male, yes female, no female, for a total of 1,276 respondents. So we've lost about a third of the data here because about a third of the respondents were either not asked or did not answer the question related to fear. So let's close this because we're going to see this represented again in another moment. And I'm going to go back to my command. So again, analyze descriptive statistics across tabs. Now this time, instead of just simply clicking OK, I'm going to go over here to where it says statistics. And you can see right here at the top on the left-hand side is an option called the chi-square. So let's say continue. And also notice, by the way, over here we've also got cells. We're going to come back to that in just a moment to make things a little bit easier for us to talk about. But for the moment, let's just leave it the way it is, and then I'm going to say OK. Now, we get the same information we got a minute ago. Here you can see valid versus our missing cases. Again, we've got our frequency count by cell. But also now, we've been included the chi-square test statistics. And the one that we're interested in right now is going to be the Pearson's chi-square value. And what you can see here is that we actually have a chi-square value of about 64. Now that's enormous. With 2 rows and 2 columns, our degrees of freedom is equal to 1. The way we calculate it is rows minus 1 times columns minus 1 equals the number of degrees of freedom. In this case, that's 1. And with an alpha of 0.05, which would give us a critical value of about 3.84. So we have far exceeded that. So, once again, with an analysis like this, you're going to reject your null hypothesis. Null hypothesis being that these variables are not related. And in fact, it seems quite clearly that they are related. Again, as always with your significance test, you can see here that it is listing 0.000. As always, as a reminder, it is never actually equal to 0. It might as well be 0 to some extent, but it's never actually equal to 0. And in fact, if we double click on this, and we can close that, and just put our cursor right over there, you can see that the actual value for the Pearson's chi-square significance, it's 9.95 e to the negative 16th, which means that we have to move that decimal place 16 times to the left-hand side to measure that significance value. In other words, the odds of this relationship occurring by random chance, in other words, suggesting that there is no relationship between fear and sex, is incredibly remote. It's very unlikely to have occurred. So one last thing I want to do, because ultimately this is everything the chi-square really does for us. Let's close this real quick. And then one last thing I want to do is I want to go back to this command. And again, apologize. Again, you can see here we have sex and rows. We have afraid to walk at night in terms of our columns. Now, the numbers are fine, but ultimately as we report this, we don't really necessarily want to keep reporting counts. Instead, we want to have an easy way for us to be able to interpret the findings. So in this case, the row is really what we're interested in the sense that we're talking about the difference, or trying to compare across men and women. That's the assumption here, right? That if our hypothesis, our independent variable includes the variable of sex, then there is some expectation that men and women are going to respond differently on this question. So what I'm going to do this time is, in addition to leaving the chi-square value on, even though we already know it's significant, and that's fine, I'm going to leave it on. I'm going to come down here to cells, and you can see the default is always observed. Now, we could do expected, but it doesn't do much for us. We're not really talking about the formula for the chi-square here. If we wanted to, we could, but let's not worry about that. Now, again, we said that sex was reported in the rows. So let's turn on the row percentages as well. I'm going to say continue, and then I'm going to say OK. Now, everything here is exactly what we saw before. So on the top, you've got your 2/3 of the data being used, 1/3 of it missing. On the bottom, you've got your significance test, still the same value. The only thing that's changed here is now, in addition to the frequency count, so instead of just saying that 124 men versus 454, 124 men said yes versus 454 men who said no, we've also got the percentages. Now, what that allows us to see is not just the count, but the percentage within the row, because it's a row percentage. So here you can see that about 21% of the men, so 124 out of 578, is 21.5%. So ultimately, 21% of the men said yes, they're afraid to walk at night. On the other hand, we would say about 43% of the women reported being afraid to walk at night. So in other words, it's now, instead of using the counts, we can report these percentages, which makes the process a little bit easier for us. In other words, it goes from having, since men and women are differentially represented here, so there's only about 580 men, but there's about 700 women. The counts don't help unless we control for that total number. So the percentage is a really easy way for us to be able to do that. Ultimately, this is the most important aspect of being able to use a chi-square. As always, if you have any questions, please don't hesitate to contact me. Let me know. Have a great day.